Hi everyone, I'm Professor Rad, and today we're going to talk about the distributive property. So let's start out with a definition. The distributive property states that you can distribute multiplication over addition or subtraction. I think of this as kind of like distributing candy to people, like on Halloween or something like that, where you take your bowl of candy and you give everybody a piece of candy. You kind of pass it out to each person. So the distributive property sort of passes out the multiplication to everything that's in parentheses. So let's look at a few examples. So here on the left, I have 5 times, and then in the parentheses, I have 2 plus 8. This is setting us up for distribution. The distributive property says I can take that 5 times and distribute that to the 2. So I would get 5 times 2. Then I have the plus, and I can distribute that 5 to the 8 as well. 5 times 8 over here. So yes, this does demonstrate the distributive property. Now let's see if this actually works, right? So like I've kind of told you that this works, but let's see if it works. So I have here 2 plus 8 by my order of operations. I've got to do that first. So 2 plus 8 is 10. And then 5 times 10 is 50. On the right-hand side, 5 times 2 is 10. And 5 times 8 is 40. And then we want to add those together, and we get 50. So we get the same thing on both sides. Okay. Now with B, I don't know if I made a mistake in my typing here, or if that was just meant to be this way, but I think I likely made a typo. So we're going to do part B in 2 ways here. Okay, so I think I might have a typo on B. So the way that this is written, it does not currently demonstrate the distributive property. So let's see why. So we have 3 plus 6 times 2. And does that equal 32 plus 62? Well, 3 plus 6 is 9, and 9 times 2 is 18. And 32 by itself is bigger than 18, so these two sides can't be equal. I think what I meant to have here was this expression, which does show the distributive property. So here we have 3 plus 6 with 2 on the right, and then we have 3 parentheses 2 plus 6 parentheses 2. And what we're doing here is we've distributed this multiplication of 2 from the right-hand side into the things in the parentheses. So we have 2 times 3, that's here, the 2 times 3. And the 2 times 6, here's our 2 times 6. So if we work that out, following our order of operations, 3 plus 6 is 9, and then we would have 9 times 2, which is 18. And then over here, if I do 3 times 2, I get 6, and 6 times 2, I get 12, and when I add those, I get 18. All right, let's look at a couple more examples. So in C here, I've got 2, and then in parentheses, 7 minus 4 plus 1. So if this is showing the distributive property, that would mean I would do 2 times 7, which I've got here, minus 2 times 4, which is here, plus, which I've got, 2 times 1, which is 2 times 1. So yes, that one is showing the distributive property. Let's look at one more. So I've got 4 and then 3 times 7 in parentheses. And I've got 4 times 3 times 4 times 7. So it looks like we did 4 times 3, 4 times 3, brought over our times, and distributed to the 7, 4 times 7. So no, this is not the distributive property. Wait, what? Why not? So if I go back up to our definition of the distributive property, it states that you can distribute multiplication over addition or subtraction. So that means the operation in those parentheses has to be adding or subtracting. On this example, we have multiplying. And if you have multiplying on the inside of the parentheses, it does make a difference. Let's check. 3 times 7 is 21. And 21 times 4 is going to be 84. On the right-hand side, 4 times 3 is 12. And 4 times 7 is 28. Hi, friend. 12 times 28. Bigger than 84, 336. So this example was a little sneaky one to make sure that what you have in the parentheses needs to be either adding or subtracting if you're going to distribute. Now, we've actually seen the distributive property. We've actually already been using it when we've been using the box method of multiplying numbers. So in this example, we had been multiplying 267 by 38. And I want to show you how this is using the distributive property. So I'm going to split, let's split 38 up. So I've got 267 times 38 is the same thing as 30 plus 8. Now I can use the distributive property here and do 267 times 30 plus 267 times 8. Then what I can do is I can split 267 up into its component parts. So 200 plus 60 plus 7 is what you get when you break up 267 times 30. And we'll do the same thing here. 267 is 200 plus 60 plus 7 times 8. And now I'll distribute the 30 to each of those pieces inside the parentheses. So 200 times 30 plus 60 times 30 plus 7 times 30. And over here, we have 8 times 200 plus 60 times 8 plus 7 times 8. And if I look at what we did with our table method, this is exactly what we did. We have 200 times 30, that's this first box. 60 times 30, that's this box. 7 times 30, that's this one here. Then we had 200 times 8, 200 times 8, that was this box. 60 times 8, that's this box here. 60 times 8 to get here. And then 7 times 8, that's this last one, 7 times 8. And then here we added them all up. So we've secretly been already using this method in our method of multiplying large numbers without even realizing it. The distributive property is actually one of the coolest properties, and it is super important in algebra. It lets us do lots of really great things with letters that we wouldn't have been able to do otherwise. So if you're one of the folks who's like, why are there letters in math? Well, you can thank the distributive property for allowing us to be able to work with them. So you can decide whether you want to love or hate the distributive property. In the meantime, let's continue to work with it. And we've got a few problems for you to try out here. So try to decide whether each of these equations is demonstrating the distributive property or not. In our next video, we're going to see some common places where students like to try and distribute, but we find out that we can't. So, looking forward to seeing you then. In the meantime, have a great day.